Hi everybody, Janice here from the Contessa. Today I have something a little bit different on the machine, so I thought I'd walk you through the process that I'm going through. If you're a CNC person and you're cutting plastic on your machine and your vac table doesn't work, or at least it doesn't work the way that you normally do, I'm going to show you how to make it work for your vac table and for your CanCam CNC. So this is the piece that I'm working on today. It's called Pick Board, which is similar to HDPE. It cuts very similar to it as well. This is a less expensive piece of material for my client. I'm using a 3/8 of an inch pick board, and I have actually glued it to a sacrificial piece of quarter inch MDF. So these two pieces were glued yesterday. I let them cure overnight just to make sure that it had nice adherence to the piece. I've actually used masking paper between the two layers. I added super glue on this side, then glued it directly to this board, let it set overnight, and then this is now acting as the vac table, the connection between the two pieces, between the vac table and my piece. Normally this could slide around a lot if it didn't have this piece. So if you're ever using material that doesn't work well with your vac table and you have to cut all the way through, I definitely recommend using a sacrificial piece of MDF. That works wonders. Okay, so here's what the file looks like in Aspire, and as you can see, all of the pink lines there are all of the cut lines for the piece, as well as the green boxes are all the start lines. So that's where, when your bit starts off, that's what starts on. So we're just going to open up the profile here, and then you're going to see all of these tabs. So these yellow boxes are tabs. So when I was working on these, I had to make sure that the tabs, as you can see, they overlapped each other. Because the bit had pretty much no clearance between it, I had to make sure that the tabs lined up on either side, so that when the tab ran through one section, it wasn't going to break off when the bit went across on the following section. It's moving from the inwards to outwards, so it's going to cut this piece first, then that piece, that piece, that piece. I believe it's actually on this piece right now as we speak. So these tabs seem to be holding up pretty good. So as you can see, the little green lines here are where the tabs are going to be in each section. They don't have to be exact, but as you can see, I still have one section in here in the middle that I know that this is going to connect with this. This will keep the entire piece from basically flying up, breaking a bit, or losing the piece on the machine. So this is just a quick overview of what this piece does. The total time for the cut on this one, because I'm being a little bit conservative on my timing, is just about 4 hours. However, totally worth it. The client is actually going to be using these for car audio parts, so I'm looking forward to see what it looks like when it's all done. Okay, we're going to get into a little bit of technical stuff. Here, the feeds and speeds and the bit. So the bit I'm using is an 1/8 of an inch O-flute bit. For the tool clearance, we obviously need the 1/8 of an inch rather than the 1/4 of an inch, which I could probably run a whole lot faster, but we'd be able to cut out less pieces because we have just barely even just a little bit more than 1/8 of an inch clearance between the pieces. So we either would have to cut less pieces or use more material. So in this case, what we're using is just perfect. For feeds and speeds, I'm running at 12,000 RPM. The speed is 100 inches per minute, and the depth of cut is 0.1 of an inch. I probably could go a little bit more aggressive on both of those. On the last two, the spindle speed is fine, 12,000. But in this case, I'm getting good chips off of the machine now, so I'm happy with the numbers that I have. And yeah, so everything's turning out well. I could probably, again, be a little bit more aggressive next time, but I'm happy with the chips I'm getting now, so it's a good place to start. Well, let's see what it looks like when it's all done. Okay, the sheet is all done, so let's take a look to see how everything went. So here is the final completed sheet. It's got all of the pieces cut out, and thanks to gluing the plastic down to the sacrificial MDF board, none of the pieces popped out of the machine while it was cutting. As you can see, it's still attached here, and that will come off because of the masking paper that's attached to the bottom or the back of this sheet of this plastic piece. That will pop off the plastic, no problem. The MDF is a throwaway piece, so that's all done too. Here is that oval piece I was showing you in the Aspire files. So if I hadn't had clipped those together, then that definitely would have popped out. So it's nice to see that those all stayed in. All these little small pieces, I have tabs in the corner here and here, which are easily clipped off with an X-Acto knife, or if you have a multi-tool, then that would also get rid of that. But yeah, sheet is all done. All the pieces stayed intact, and this is ready to be delivered to the client. I hope that helps if you are looking to do plastic on your CNC machine and have a vac table that it won't stick down to. So I hope that helps you. Thanks guys, talk soon, bye.